So welcome to our podcast today. We're happy to join everyone again. And if you're watching the video, you might see that we have our little puppy Zinni with us today. She's been barking up a storm. It's been super fun, but hopefully we'll calm her down in the first few minutes. For our topics today, our first two topics are really the same topic. They have to do with laser cutting. We spent a lot of time last time with 3D printing. Today we want to talk about something else we do a lot of, which is laser cutting. Our first one is really around different things that you can do, some things that might be familiar to you, different materials that can be cut with lasers, different uses and ways that we've used that within escape rooms. Our second topic takes it a little bit further and how those can be assembled. So we might just be cutting something out sometimes, but other times we're using those pieces to assemble part of a larger prop, sometimes very large props. And our third topic is another surprise for Evan, which he doesn't know about. It's going to be great. And by that, I mean, even I was frustrated with this one, so he'll love it today. So I'm going to go ahead and put Zinni Pup down and we'll get started with taking a look at some of the things that you can laser cut.
Yeah. Not much of a puppy though. I think she's 8 now.
She's 8.
So have you ever been shopping on vacation and you noticed something like this? So this is from Tallinn, Estonia, and I thought it was really neat. And it is a laser cut little magnet. So they just glued some magnets on the back, and they put a coin from the local country in there. And so this is all cut with a laser. So they cut it all out, and then it has a couple of different pieces. So they've glued it together, and they have cut individual lines into the surface. So these are cut lines, and this is really fast to do. So the laser moves over this extremely quickly and is able to probably cut this whole thing out in, what do you think, a minute, 30 seconds, something like that?
A minute and a half, maybe, if that has some detail on it, but
if
not
you have a
at all.
Professional laser. I mean, something like a Glowforge will be slower, but... And then this is another one, and
a little simpler.
Yeah, this one's a bit simpler, and so it was cut out, but it was also rastered. And so the difference is a cut is a single line. The laser actually moves in the shape of the line, and it's quite fast. Rastering, which is what they've done to actually carve out this little hole, is done by moving the laser back and forth across that space over and over again.
Think of it kind of like a 3D printer, or not a 3D printer, but like a dot matrix printer from very many years ago, how it would go back and forth really, really slow.
Yeah.
That's what rastering basically is in the laser.
Yeah. And so since a laser can only take off something like 0.02 inches at a time, you end up having to do that a whole lot of times in order to get rid of all of that.
Right. So this one looks simpler, but it might have actually taken more time on the laser. We're uncertain on that because we didn't do either of these pieces. But with our machines, it might have taken more time to do the turtle than it did to do the talons.
Yeah, and actually, this is a hardwood, whereas this is just plywood or something. Yeah. And the other thing you can do in rastering, so is generally when you want to cut lines like this, they're very, very thin and crisp. But with rastering, you actually sometimes can defocus the laser. So you pull the laser a little bit out of focus, which will cause the laser beam to be wider, and then you can take less passes to actually carve the thing out. So something to think about. So we wanted to show you those as things that you've probably seen in your day-to-day life that are laser cut. And then we talk a little bit about some of the stuff that we've laser cut. Here's the most silly one. We were testing to see if a certain laser cut design was going to work for us. And one great thing about the laser is it does great with cardboard. So this is just corrugated cardboard from a box, and we cut it out just to make sure that the sizes and everything was going to fit together for our project.
And that's a lot of times what we do for testing is cardboard, because it's much cheaper than the wood.
Yeah, tons of stuff in cardboard. Yeah. And then another thing, this is another test pattern that we did to try to see if we could cut something out. So this was cut into, I think this is 1/8" plywood. 1/8" plywood, and it looks really nice. It has a lot of really fine cuts, and you can basically see that as we were cutting it out, all of this wood that's in the inside has to go somewhere, and so what you end up with is a whole bunch of little pieces that fall out. And so here's an example of a big piece.
Right. So we were making a prop that had a lot of layers, and we'll show you a little bit of an example of that later. But as we were cutting that out, there's a place where a token goes. We have to cut that hole out. Now we have this extra piece left over. A lot of those pieces we end up using to make the tokens that went in that place, but we still had way more pieces left over. And we've just been saving those because they're really good handheld size. And eventually we figure we might have a use for them.
Yeah, well, I think everybody who's a maker has this problem. Little pieces of wood and scrap that are, potentially useful. This is actually slightly an oval. It's not actually a circle, but we have a lot of them, and we do use them all the time. And as a bare minimum, we use them for things like mixing epoxy because they're basically trash.
I've mixed epoxy on those pieces many, many times.
Yeah, and so this is kind of fun. So this is hardboard, which is roughly 1/8 of an inch thick. It has a smooth surface on one side that's sort of a glue surface, and then on the back end it's rough. And I'm sure you've seen this before. It's what they make pegboard out of. This is really popular to laser cut because it has this nice smooth surface on the front. It takes paint okay, and it's cheap and it's thin, which means that it cuts fairly easily. And once it's cut, it holds up quite well. And unlike plywood, which this is plywood. Plywood is a natural product, and so even though it's made and designed to be flat, like even if you look at this one, I'm not sure you can tell in the camera, but it is not flat. And so over time, plywood has a tendency to curl, depending on the kind of plywood and where you get and its quality and all of that kind of stuff.
And there's a problem on that piece too. If you flip that over, and then on the top, this side, there's a line that goes across. I don't know if you can see it, Evan, so you can point it out better.
Yeah, right here.
That line was a problem for us in this particular cut too, because that was an area that was extra dense. And so while our laser cut through all of the other pieces of the wood extremely well, along that specific line, it didn't cut through at all. So those pieces didn't fall out. And I actually had to use tools to get those extra pieces. So sometimes with plywood, there'll be pieces that are a little bit more dense or have extra glue or have something about them that just doesn't cut as well as other components. And so you just have to be willing to fiddle with it a little bit after to get those to come out.
Yeah. And so this is not quote unquote laser grade plywood. We don't typically buy laserable plywood because it's like 6 times the price of regular plywood. But they definitely do make plywood that only uses glues and wood pulps that are easily compatible with the laser. If you buy stuff from Home Depot, which I'm pretty sure that's where this came from, you will find that there is sometimes like bits of bark in the center, even if it's a fairly high grade plywood, or they'll use a certain type of glue that is less laserable. So it absorbs the energy from the laser instead of cutting very nicely. And so there's a full range of plywoods, and you can go all the way from cheap plywoods to very expensive plywoods, but this is the cheapest of the birch plywoods. And so that's what we're looking at here. Revel, which is actually a model company, makes a really nice 1/8 inch plywood that you can get at Michael's or other hobby stores. And it's actually a bit more tolerant of the laser without being at the cost of laserable plywood.
And my dad gets his plywood off of Amazon. He goes and buys 1/8 inch bulk sheets of plywood for his projects too. And that's another cost effective way if you know you need a lot of material.
Yeah. And we have a table saw and the ability to cut down large pieces of plywood. But when you're getting this thin, what we find is that you end up with a lot of twisting and unlevel wood.
So the smaller the piece, the less likely that is to have been a problem.
Yeah, definitely. And so even whenever you're lasering something, so the laser is you have to focus it, and you focus it down to a millimeter basically. And so even if this piece being unlevel, so if we notice that it's high, this would probably laser okay. But if it was just a little bit worse, it would be a problem. And so what we do is we take chunks of steel, and just plop it at the corners outside of the frame of where we're lasering. And that holds the wood flat against the surface so that we can cut it. And then, of course, as this cuts out, it will eventually become loose from the plywood that it's attached to and kind of pop up a little bit. And that, honestly, that's kind of nice because it's great to be able to see, oh, look, it actually did get cut out. Because the other problem potentially with laser cutting things is you cut the whole thing out and then you go in to touch it and you realize that it didn't cut all the way out.
You moved it.
And you need to cut it again. Yeah.
And that's not a good time.
Don't ever move it. Always leave it still until you're sure that it's cut out. One thing I've seen other people do is they actually cut up on a raised surface a little bit. And so what happens is as they're cutting it out, the object will actually fall. And so it's obvious which ones have fallen. Our laser, we're using a Thunder laser. Our Makerspace has 4 or 5 of them. And it uses a honeycomb surface, which is fairly common.
So on this particular piece, it was really obvious if something was falling out of it or not.
Yeah, because you could just kind of see it fall through the honeycomb. And even a bigger piece, generally you can kind of see it shift a little bit as it's cut. And so that's good enough to tell you that your cut has actually succeeded.
And then we have a couple more examples. These two here, we'll start with the wood one there, but that's just another example. It's very similar to that piece that he was just showing you. It's made out of the 1/8 inch birch plywood. It's got the cut around the outside. It also has some cuts on the inside, similar to that Tallinn magnet, where it's using the laser just as a cut with less power to put some design onto there. But the neat thing about this, and this is something actually my dad cut out, the neat thing about this is he also then went back and did that in acrylic. So that other piece that Evan has, lasers are useful for not only wood or cardboard, but they can be used on acrylic too. So this is the exact same pattern, but it's done on acrylic, and you can see how having those surfaces make it shiny. It gives it some texture. And so there's a lot of versatility. It's nice. It's nice for us for the wood aspect, but sometimes having it available for acrylic is equally useful.
Yeah, definitely. And so and just to kind of clarify what I was talking about earlier, and Judy mentioned this, is these are cut lines, and they're just at a really low power. So you set the laser at 15% power, and then you just move really fast.
Right. You could raster that, but doing that as cut lines instead reduces the amount of time that the laser takes.
Yeah, definitely.
All right. We have another example with acrylic and then also felt. These are some pieces that we were working on for one of our friends' escape rooms. And we ended up not using these. There were some problems with that tail there. The connection joint was just too small and people kept breaking it off. So we did not end up using these. But it's pretty neat because not only then can you cut acrylic, but we used it to cut felt. So a lot of times when you're working with pieces that need to rub over each other, you don't necessarily want to rub acrylic on acrylic or wood on acrylic or wood on wood. You can also cut felt with lasers, and just you have to turn the power down a lot. And the nice thing about cutting felt, which you really can't tell when looking at it, but it also kind of, because what felt's made of, it also kind of sticks those edges together so that it's not going to continue to frizz as people are using that piece.
Yeah, you get a nice cauterized edge. So, and then we were able to glue these up, and I think we'll show an example of that.
Go ahead and get that now. It's kind of our next segment, but we glue them up. So we cut a couple of different pieces, and these again are out of plywood. It's the same design, but on the second piece that's on the back, we added a little hole for the magnet in there. So, and then the other piece has the felt on the back, but you can put the felt on. So that's really what he has on the other piece, is just the whole thing assembled. So it's really a horse with a magnet that has some felt. We actually have both of those hanging up on our magnet wall in the house right now. It's a nice, pleasant thing for us to look at from time to time to see projects that we finished up and around the house. But it's a neat component for us to take a look at for that too.
Yeah. And then we have one more fun thing, and that was we had a customer who was doing an escape room. It was a Sleepy Hollow escape room. And we made them a sign. So this was kind of a surprise, but we were actually playing at the Makerspace, and this was in the trash can, this piece of wood. It is a beautiful, destroyed, ugly, moldy piece of wood. It was already cut like that. We didn't have to cut it. And then so all we did was throw it in the laser and quickly find a font and write up Sleepy Hollow. And you can see it. We rastered this, so it took a little bit of time. If we get kind of close, you can actually see the lines where it was rastering. But you can't see that from far away.
I just think it looks neat, especially on the L on Hollow, because it just looks neat to me. I just love how it has an actual shape of the wood. And if you look on the back, you'll see that this is a pretty new piece of wood.
Well, it was a new cut on the back.
It was a new cut on an old piece of wood. But so it's still a pretty good structurally, but it has a pretty neat design.
Yeah.
In my boat, it looked.
And we rastered this at a fairly high power, and so what that did, it cut these lines out quite a lot. So you can see we actually went down almost like a 30-second here.
Yeah, and you can see some of the shadowing on there too, which is something that sometimes happens with laser cutting. You'll get that, you can see kind of to the left of each of the shapes, like on the H, there's that kind of smoky appearance to the left of the H there. And that's something that will sometimes happen. A lot of times when we're doing rastering like this, we do go back over it later with sandpaper, but because we were really looking for the old look on here and we didn't want to get rid of any of that surface, we left it. But a lot of times we do end up sanding that off later.
Yeah, and it literally is just the smoke. So as you raster something, it will billow smoke out. And if you don't have a surface down to cover that, then it's going to stick to your project. And so that's what happened in this case. Another thing that's really common is you can put a mask, which is basically literally masking tape. You can cover the thing in masking tape or painter's tape. And then when you cut it, all of the smoke will stick to that painter's tape, and then you just peel it off, and then you end up with a perfectly smooth surface without any smoke on it, because the laser doesn't care if there's tape. It cuts right through it.
And a lot of times if you're doing like a tumbler, which we've done some like mugs or tumblers, and you're cutting through the paint to get to the exposed metal, you'll end up using a masking tape or something on that because you don't want the bright blue to be covered in smoke later and have to clean that up.
Yep.
Okay. We're going to go ahead and move on to our next topic. So give us 1 minute and we'll get situated for that piece. And then we'll talk about some of the things that we've put together beyond just those magnets.
So we're going to look at a couple of projects that you can do with laser cutting. At least the ones that are small enough to fit on this table.
Done some massive laser projects. In fact, the first one, we'll start with that one. This one here is just a prototype. When we made this as a final prop, it was a full circle, and it was 4 feet wide and weighed a ton. And installing it was not the most pleasant experience of my life. I laid on the floor lots of different times, but it worked really well. And the nice thing about this one was it was a good combination of laser cut materials along with electronics. Everywhere on there that you see a shape cut out with the little bitty letters on there, we filled those with acrylic cut pieces. We put lights behind them, and the lights move through a sequence basically. And then we talked about the little pucks, the little like leftover pieces that we had. Those were what came out of the circles that you see kind of in the cavities on the top part of that curve. We cut those, and then people put a token into there. So we did use a lot of the different leftover tokens and such in order to fill and simplify that prop. But this was pretty neat because this was a mock-up of that. So we're able to do this at a handheld size, and you'll be able to see if he turns that exactly how many layers and the different layer designs and different components that were part of that, so that we could accommodate having the lights in place, having the electronics run back there, having the RFID readers run in place. There were a lot of different moving parts here in order to make this a fully functional prop.
Yeah, so this ended up being a 5-layer design, which we glued up, and you can kind of see the little holes where the different LED lights went in, because we wanted it to be able to light up each individual letter separately. So there's, if you look in there, very
detailed, there's little bitty circles that are in there, and each light went within one of those cavities.
Yeah, and with an acrylic back. And so it was a very, very neat prop. And this is a 10% scale, I forget. But the wonderful thing about laser cutting is we were able to just go in the software and say, cut it at 10%, and then we threw a piece of wood in there, and then voila, this came out. And so
we're just wanted to make sure that this is what the people we're making it for really had in mind for what that needed to look like. Before we went through and cut massive sheets of MDF up in the laser.
Yeah, and here's another example of rastering. So this is rastered, and then we didn't mask it, so you can see the smoke on the edge of that. And then these were cut instead of rastered.
And it's also a good example of changes in our design ultimately at the end. Our final design for this, that piece in the middle, as well as the tokens, we did not use the laser for those. We actually used the Shipoko. And when we did that, then when we had that, it was really hard with the laser to just do that. It was time consuming. We ended up using the Shipoko because we could take out the material, give it some texture, paint it, and it just looked like an overall nicer finished product for people to be physically manipulating in order to put that in the prop.
Yeah. So one of the challenges with a laser is it's really hard to do depth. You certainly can, but it's a challenge. So usually whenever you see a laser cut project that has depth, it's because they're cutting individual pieces and then gluing them together. In the final version of this, for this little coin and also these coins, which have ended up being about that big, we pocketed them out of a piece of wood, and so they actually had a three-dimensionality to them and a 3D design, and so that we had to do on a rotary mill, which is what the Shipoko is, and so you just kind of put a bit in there, it goes around, carves everything out, and it gives you a nice feel. Laser is beautiful and fast and easy and accurate down to tiny little tolerances, but it's not very good at making a 3D design.
Which ended up being nice in the long run there.
Yeah.
All right. So we'll go ahead and move on to another piece that we made. This one, I wish I had more examples so that we could show you just how flexible some of your 3D print or 3D printing, again, we're laser cutting, some of your laser cutting material can be there. This piece that's around the outside actually started out as a flat piece of 1/8 inch birch plywood. But because of how you can cut that, you can see that there's a really nice pattern. You can actually make flexible hinges on there. So there's people who use this to make books, to make pretty little designs, which is basically what we've done. In this case here, we were working on a prop a couple of years ago that we've clearly not finished. This was just something we were playing around with before we got busy with making props for other people. But the idea here was it would have a clock, you put the hands in the right time, and then and if you look, Evan will lift it up, the bottom pops open. So everything in this except for that hinge piece is something that we laser cut and then glued together, just using regular wood glue. I did make some mistakes on gluing that up with the edges and stuff, but it's just a nice way to see how there's just a lot of options when it comes to using the laser cutter, because not only can you cut physical shapes out that you can manipulate, but also the piece that you laser cut can be flexible. And then this here is just a really good example of how we were able to round that over. And if you were to do that with a traditional piece of wood, you would have a lot of waste after cutting that particular piece out, but this makes you have really very little at all.
Yeah, and if you want to find examples of this, it's called a live hinge, and it's really easy to do on a laser, but you can also do this on a table saw. And so I've seen people, I think Adam Savage from Tested did a poker table that had a live hinge that he cut on the table saw. But there's maybe 15 different designs that are popular for these live hinges. And Judy, I think, actually designed this one herself. And it creates this wonderful flexible material that's actually quite durable over the long term. So
pretty neat. It's held up for 2 years, sitting in a closet. So it's done a really good job there. Yeah. But hopefully over time we'll get that one finished. Our big holdup on finishing that, there were 2 things. The clock hands, in order to get a magnet in there that could read and actually register the electronics, it had to be a little bit bigger than we thought looked good on this particular clock. So we're trying to think of a better way to accomplish that. Maybe a bar magnet instead of a circle or something along those lines. And also, if you notice when that door opened, it didn't open very far. And so you're really limited on what you could potentially put in. And also there's some potential weakness there that if a player decided to try to pry it open, it could potentially break. So I'm just trying to find ways around those 2 limitations before we go and start building that out a little bit more. And it may just be that it needs to be larger so it can be more durable.
And then this is another thing that you can do with laser cutting. So this is a project by Laser Art by Cook. And this is Judy's father-in-law. And
he's my dad.
He's my father-in-law. So this is cut out of different colors of acrylic and glued together. And so it's quite a project. And it has a lot of different pieces. And then gluing a clear acrylic together so that you cannot see the glue is a bit of a challenge. So you have to get the right kinds of glues.
Yeah, there's very special glues, especially for gluing acrylic together. So if anyone's making acrylic boxes and they don't want the edges to show or they don't want that seam to show, there's very specific chemicals that they'll use to do that particular process. And a lot of times it's hard. You won't be able to buy them in a hardware store or Home Depot, Lowe's, anything like that. So if it's clear acrylic, you'll have to be really careful on what you're using to put those 2 different pieces together. But you have a lot more options when it comes to the black or other types of acrylic.
Yeah, and I believe the glue is called MEK, and I forget what it stands for. It's a chemical compound. But the other challenge with these is no matter what glue you use, you'll be able to see it underneath this surface if it's not completely uniform. So you have to literally coat the entire back of the clear pieces with that glue and then stick them in place and then clean any squeeze out. And that actually allows you to get this really clean, smooth surface.
I thought that was a pretty neat piece just because it demonstrates like there's a lot of flexibility. You don't have to stick with one material. And then again, on the bottom, he's put some felt on there. So just another example of how you could use felt. And felt's a pretty common, in fact, it's the same color as the one I use, surprisingly. But felt's a pretty common combination with some of the stuff that we've been using with the laser cutter.
Yeah, and I think you can get this felt in 12-inch sheets from any hobby store.
Yep. And then if you need bigger pieces, if this is a thing, if you go to like Joann or any fabric store, they're going to have bolts of felt that you can buy. So instead of buying individual 8 by 11 sheets, you can get full like 45-inch wide sheets of felt, which we've done for several props as well. All right. Evan's hesitating to put that away now. So I'm going to get those out of the way because I have a beautiful, lovely surprise for him.
Okay.
Doesn't he sound really happy?
Oh.
I want to talk about that for several reasons, but mainly because of glue.
Yeah. So this is what is often referred to as a ball pit ball. These are soft. So there are soft ones and then there are hard ones. And it depends on the kind of plastic that they're made from. This is a polypropylene ball, which it took us a very long time to figure out what it was made from because I am not a plastics expert. But after a bit of effort, we figured it out. And polypropylene is not, it's
notoriously hard to glue to other things.
It's similar. Mm-hmm. Yeah. It's similar to a Teflon in the way that it's kind of treated with glues. And so this was a terrible choice to glue onto something. If we could have found a ball that was made out of a different plastic.
And another thing that's probably worth noting, in case you couldn't tell, Evan can squeeze that, which is another real big problem when it comes to gluing that to something that is not flexible. We glued it to the end of a PVC pipe. So very, very rigid surface.
Yeah. And so we ended up chamfering, I guess chamfering is a good word, basically creating an edge on the PVC pipe using, this was actually a project by...
my dad and I spent time, he made me a tool where I could just basically, it had a blade on it where I could just stick it inside the PVC pipe and twist it for like 30 minutes. And then it would create the chamfer at the right angle for that. And I had to do that for, I think, 48 different pieces of pipe. It took me an entire day.
Yeah. And so the challenge was getting the glue on here so that it would stick. We went through 3 or 4 different glues, did a lot of internet research and a lot of testing, and eventually found and settled on, I believe, a Loctite plastics bonder kit.
And it was a two-part.
Yeah, it has.
It wasn't an epoxy, but it was. I think the first part either dried or was an activator, and the second part was the actual glue.
Yeah, and I think it was based on cyanoacrylate, but it was not. It was some sort of blend.
It did not stick my fingers together, which was a happy find.
I mean, who knows? Maybe it's not. I'm not sure. But anyway, it was the only thing that would bond polypropylene that we could find. There are a couple of other polypropylene bonding glues, but they're quite difficult to get.
But we had to sand that ball. I had to sand all the balls before we put the glue and the activator on them before we put them in place. And even still, I mean, basically the way I tested the different glues, my dad and I tested 10 different glues with these on multiple different pieces, is we cleaned up the PVC with some, I think it was probably just rubbing alcohol. And then we cleaned up the ball. Then we put the glue on and we stuck it together according to the instructions on the glue. And then we used masking tape to hold it there overnight. And the next day when everything was all cured, I went out there and I just picked up the PVC and then hit it on a table. And if the ball popped out, we immediately ruled it out.
Yeah.
Which is how we ruled out 7 different glues that we were like, nope, that's not going to work for this project. The other 3 held pretty well, but one of them, when I squeezed the ball, the glue wasn't flexible at all. and the glue popped down, and we were really able to narrow it down to 2 glues. I honestly cannot remember what the other glue was because I spent so much time with Loctite after that that it kind of just killed that. But this was pretty easy. And the nice thing is it's not a super expensive glue, and so I was able to deliver that prop with extra pieces, extra balls, extra glue. I just gave her a lot of extra of everything. Our original design did not use these balls. It actually used PVC end caps, which would have never popped off of there. But because of what we were working on, which we'll not go into, the balls did look more like what the final result was supposed to look like. There were just some functional concerns that came as a part of that.
Yeah. Yeah, definitely figuring out how to positively affix things is difficult. And finding the right glue is really important. So what we find in working with a lot of escape room owners is they have super glue and hot glue, and those are their 2 glues. And if you can't fix it with super glue or hot glue, then you know, it's difficult to figure out what to do next. And there are hundreds of glues, and different glues are good at gluing different things, and they have to be handled in different ways and prepped in different ways. And so spending a little bit of time doing research on the right glue for your project definitely does help, and will help the project last a lot longer. Actually, Adam Savage, to mention him again, in his book, every tool is a hammer, which I think is actually the original quote was, in every tool is a hammer, which I really like that quote. He has a whole chapter on glue, and it's a great little read, and he talks about the different things that he's found over the years and how to put stuff together.
Evan got me a joke shirt a few years ago that was a stained glass window, and it had duct tape and super glue and cable ties.
And WD-40.
Oh, WD-40, yeah. Duct tape, super glue, and WD-40. Basically, if you can't fix it with those things, you can't fix it. And I thought that was always a funny thing. But in this case, definitely none of those 3 things would have helped us. I mean, the duct tape might have kept it on, but it would have ruined the overall look.
Yeah. We don't use a lot of duct tape, actually. We find that it
doesn't stay over time.
Yeah.
You'd think it would, but depending on where you're using it, if it's going to be warm, the glue can melt and it won't stay, which is kind of counterintuitive, or the material breaks down over time. Or my favorite thing is it gets taken apart by somebody who's trying to fix something, and then they end up breaking electrical components within the prop, which we just tend to stay away from it now because it's either too strong and it does a great job, or it falls apart and then bad things happen.
It also leaves a really sticky residue, and
which is super
there's
fun
definitely better tapes that perhaps have a higher cost, but they work quite nicely. And we still use hot glue. You know, people knock on hot glue, but hot glue is wonderful in certain cases. Like if you want to isolate some electronic components from each other and you want to put them in place in a way that you could get them off later if you had to.
Like if you want to relay really close to an Arduino and you want to make sure that they don't hit each other so there's not any short circuits or something, using a layer of hot glue between those two is a perfectly great way. I wouldn't necessarily use hot glue to glue it to the side of a 2x4. That might not be something that stays over time. We tend to now use brackets instead of glue in that situation, but it is something that does have its uses, and we carry it with us in our to-go bag and everything.
Yeah. And I will say that hot glue isn't necessarily designed for that. And there are glues specifically designed for electronics, but hot glue works well enough.
Absolutely. So we'll go ahead and wrap this one up for today. I hope you learned a little bit about lasers. I know if you're just listening, it might be a little hard with the examples, but we do have this up on YouTube. You can always come back and take a look at it there. If you've played any rooms that we've made props in and you recognize any of these pieces, then it'll make a little bit sense on how those might have been used during gameplay and why we made some of those decisions and why some of those decisions weren't necessarily, why they were made and why they might be a little different than what you would have expected there. And then hope you learned a little bit about glue. Glue is probably the number one thing I researched. I've looked it up in this past week. How do you glue metal to glass for something? And you learn a lot by researching different glues and different properties of those different glues. So hope you learned something. We look forward to talking to you next time as well. Bye.
Thank you.